100,000 years is a long time, long enough to forget almost everything, long enough for mountains to erode and coastlines to shift, long enough for every trace of existence to be ground away by the patient, relentless forces that reshape our planet. But it's not long enough to destroy everything, not if we're smart about what we build and how we build it. Not if we think in geological timescales instead of quarterly reports. We are the civilization we know existed, the one we can study and understand and hopefully guide toward a future that actually lasts. Whether there were others before us, we'll probably never know for certain, but we can make sure that the people living 100,000 years from now won't have the same uncertainty about us. We can leave a record they can read, knowledge they can use, a planet that's still capable of supporting civilization because we had the wisdom to take care of it. That's what matters. Not solving the mystery of what might have come before, but ensuring we're not a mystery to whoever comes after. The story of Earth is long. Civilizations might have risen and fallen before ours. They might rise and fall after us. That's the nature of existence on a dynamic planet that's constantly changing. But right now, in this moment, we have the chance to be the civilization that lasted, the one that learned from mistakes, planned for the long term, and built something genuinely sustainable. We carry in our genes the potential to survive almost anything. We're descended from people who made it through the worst climate disasters, the most brutal conditions, the closest brushes with extinction. That same resilience is in us, that same adaptability, that same refusal to give up even when circumstances seem impossible. The question is whether we're wise enough to use those traits before we're forced to. Whether we can look 100,000 years into the future and ask, what will they find when they look for us? What will they know about who we were? And then build accordingly. That's the real lesson of thinking about lost civilizations. Not that they existed or didn't exist, but that civilizations can be lost. That everything we build and know and value could disappear if we're not careful. So we should be careful. We should build things that last. We should preserve knowledge carefully. We should think beyond our own lifespans to the deep future. Because 100,000 years from now, someone might be wondering about us the way we wonder about possible ancient civilizations. Let's make sure they don't have to wonder. Let's leave them answers instead of mysteries. That's how we honor both the potential ancestors who came before and the certain descendants who will come after, by building something that actually lasts. Because here's the real question the Silurian hypothesis raises, not whether ancient civilizations existed and disappeared, but whether any technological civilization can survive long term. Every species that's ever existed has eventually gone extinct or evolved into something different. That's the rule demonstrated across billions of years of life on Earth. The average species lifespan is a few million years. Modern humans have existed for 300,000 years, advanced civilization for maybe 12,000 years, industrial civilization for about 250 years. We're not even getting started yet in evolutionary terms. We haven't proven that intelligence is a long-term survival advantage. If we make it to 100,000 years as an advanced civilization, if we spread beyond Earth so no single catastrophe can destroy us, if we develop sustainable relationships with our environment, maybe then we'll have earned some confidence in our long-term survival. But right now we're fragile, dependent on systems that could collapse, facing challenges that could set us back centuries, making decisions today that will affect the planet for geological timescales. And if we fail, if our civilization collapses and humanity reverts to simpler ways of living or goes extinct entirely, in 100,000 years there might not be much evidence we were ever here either. Future archaeologists, if they exist, might find a few puzzling artifacts scattered in geological layers. Some odd chemical signatures. Perhaps stories passed down through countless generations about ancestors who could fly across the world in hours, who could speak to people on the other side of the planet instantly, who visited the moon and sent machines to other planets, and they'll probably dismiss it as mythology, as impossible, as fantasy born from prehistoric imaginations trying to make sense of the world. Just like many academics dismiss stories about advanced ancient civilizations today, the cycle could repeat over and over across geological time. Civilizations rising, achieving remarkable things, then collapsing and fading away until nothing remains but distorted legends that no one quite believes. Or maybe we break the cycle. Maybe we're the ones who figure out how to build something that lasts not just centuries but millennia. Not just millennia but hundreds of thousands of years. Not just physical structures, though those matter, but systems of knowledge preservation, social organizations that can adapt to changing conditions, technologies that enhance rather than degrade the environmental systems we depend on. That's the real significance of asking whether an advanced civilization existed 100,000 years ago. Not because the answer tells us definitive facts about the past, but because the question forces us to think seriously about the future. What do we want to build that will actually last? What knowledge do we need to preserve? What kind of ancestors do we want to be for people living thousands of generations from now? These are questions every civilization should grapple with, especially when facing the possibility that we might not be the first to face these challenges. So what if Earth had an advanced society 100,000 years ago? We don't know. The evidence that might prove it either doesn't exist, hasn't been found, or has been destroyed by geological processes. We might never know with certainty, but the question itself is valuable. It reminds us that human history might be longer and stranger than we assume, that our current civilization isn't inevitable or permanent, that the knowledge we've accumulated could be lost if we don't work to preserve it. It reminds us to look at ancient peoples with more respect, to consider that they might have been capable of more than we give them credit for, to question assumptions about the linear progression of technology. Most importantly, it reminds us that we're part of a story that started long before us and will hopefully continue long after we're gone. What we do now matters. The decisions we make today about resource use, environmental stewardship, knowledge preservation, and long-term planning will determine whether our civilization is remembered or forgotten. Whether 100,000 years from now, our descendants look back at us with clear knowledge of what we achieved, or whether they puzzle over fragmentary evidence, wondering if their ancestors could possibly have been as advanced as the myths suggest. The choice is ours. We can be the generation that learned from history, even the parts of history we can't quite prove. The generation that built something meant to last, not just for our children or grandchildren, but for people living thousands of generations in the future. Or we can be another chapter in Earth's long history of civilizations that rose, flourished briefly, and disappeared into geological time, leaving nothing but questions for whoever comes after. Maybe right now there are archaeologists on other planets wondering the same things we're wondering, looking at anomalies in their geological record, finding suggestive artifacts that don't quite fit, debating whether their world had previous advanced inhabitants. Or maybe intelligence is common, but most civilizations don't leave detectable traces because they develop along paths different from ours. They use materials and technologies we wouldn't recognize. They exist in ways we can't imagine because we're trapped in thinking our industrial path is the only path. What if most civilizations never develop radio? What if they use different communication technologies that we're not monitoring for? What if they don't pollute their atmospheres because they develop clean energy from the start? What if they build underground or underwater where their structures wouldn't be visible from space? We'd never detect them. They could be everywhere. And we'd never know because we're looking for signs of civilizations that developed like ours. This is what the Silurian hypothesis really asks. Not whether there was a specific ancient civilization on Earth, but whether we would know if there had been. Whether detection is even possible given enough time and the right conditions for evidence destruction. The answer appears to be probably not. Not with certainty, not without extraordinary luck. Which brings us back to the original question, what if Earth had an advanced society 100,000 years ago? The honest answer is, we don't know. We might never know with certainty. The tools we have for investigating deep time are limited. We can study geology, analyze chemical signatures, search for anomalies in the rock record. But proving a negative is impossible, and proving something existed when all direct evidence has been destroyed is nearly as hard. What we can say is this: it's not impossible. The timeline works. The cognitive abilities were present in anatomically modern humans. The environmental conditions in many regions would have allowed for large settlements and technological development, and critically, the lack of evidence doesn't mean much. We wouldn't necessarily expect to find obvious evidence after 100,000 years of geological activity. That's not proof of anything, it's just acknowledging the limits of what we know and what we can know, but here's what really matters. Whether or not an advanced civilization existed 100,000 years ago, we're part of one now. Right now. Today. And unlike a hypothetical ancient society that left no traces, we have the knowledge and capability to leave a record that will survive far into the future. We can encode information in multiple formats. We can create archives designed to last millions of years. We can send probes into space carrying information about who we are and what we've learned. We can engineer materials and structures that future geologists will definitely notice in the rock record. The question is what kind of record we want to leave. What do we want future civilizations, whether human descendants or alien archaeologists, to know about us? That we depleted resources and changed the climate faster than ecosystems could adapt? That we fought wars over ideology and resources? That we developed powerful technologies but struggled to use them wisely? That we prioritized short-term economic gain over long-term sustainability? These are all part of our current record. The geological signatures we're creating right now include elevated atmospheric carbon dioxide, plastic microparticles in sediments worldwide, isotope ratios from nuclear testing, rapid extinction of species. Future geologists will definitely know we existed. The question is what else they'll be able to determine about who we were. Did we recognize the problems we created and work together to solve them? Did we value knowledge and try to preserve it for future generations? Did we look beyond our immediate needs to consider the long-term consequences of our actions? Or did we just consume resources until they ran out, ignoring warning signs until it was too late? If there was an advanced civilization 100,000 years ago, and if they disappeared without leaving clear traces, we should probably think hard about why that might have happened. What mistakes did they make? What challenges proved insurmountable? What did they fail to anticipate? Except we can't learn from their example because we don't know if they existed. And if they did exist, we don't know anything about them or why they failed to persist. So we have to figure it out ourselves. We have to be wise enough to anticipate problems before they become crises. Creative enough to find solutions that work long term, not just quick fixes fixes, thoughtful enough to consider consequences beyond our own lifetimes. If that's possible, why couldn't other information survive similarly long periods? Why couldn't technological or historical knowledge persist in mythologized form? Maybe stories about gods who controlled lightning are distorted memories of people who understood electricity. Maybe tales of magical materials that never rusted are garbled recollections of advanced metallurgy. Maybe legends about flying vehicles preserve some kernel of truth about technologies we can't imagine? Probably not. Probably they're just stories. But we can't completely rule out the possibility. There's a concept in archaeology called memory sites. These are locations that remain culturally significant for extremely long periods, often for reasons people no longer remember. Certain hills are considered sacred, certain caves are special, certain springs have been gathering places for thousands of years. Ask people why these places matter, and they often can't give you a specific reason. It's just tradition. It's always been important. Sometimes modern research reveals a practical reason that was forgotten. The sacred spring is the only reliable water source during droughts. The special hilltop is actually the best defensive position in the region. The cave has unique acoustic properties that make sound carry in unusual ways. The knowledge of why the place was originally important was lost, but the cultural significance remained, passed down as tradition even when the original meaning vanished. Could some memory sites be markers from an ancient civilization, places that were important 100,000 years ago for reasons we can't begin to guess, but which retained cultural significance through countless generations? Probably not. Memory sites likely develop for much more recent and practical reasons. But the concept illustrates how cultural knowledge can persist even when the reasons behind it are forgotten. Now let's talk about what we can say with reasonable confidence. Earth has been capable of supporting advanced human civilization for at least 100,000 years. The climate was suitable in many regions, resources were abundant, and anatomically modern humans with cognitive capabilities identical to ours existed. The raw materials for civilization were present. The question is whether they were actually used. We have no definitive evidence that they were, no confirmed ruins, no unambiguous artifacts, no chemical signatures that clearly indicate industrial activity. But we also have to acknowledge that most evidence would have been destroyed by now anyway. Cities would have eroded, coastlines where major settlements probably existed are underwater. Geological processes have resurfaced the planet multiple times. The absence of evidence is not evidence of absence, especially when we know the evidence would likely have been destroyed. So where does that leave us? In a state of profound uncertainty. We can't prove an advanced civilization existed 100,000 years ago. The evidence isn't there, or we haven't found it, or we've found it but don't recognize it. But we also can't prove one didn't exist. The geological processes that reshape Earth's surface over deep time would have erased nearly everything. This uncertainty has implications that go far beyond human history. If we can't reliably detect an advanced civilization on our own planet after only 100,000 years, what does that mean for finding evidence of alien civilizations? We search for extraterrestrial intelligence by looking for radio signals, examining planetary atmospheres for industrial pollutants, searching for massive engineering projects like Dyson spheres. But if a civilization rises, flourishes for 50,000 years, then collapses, what happens next? Their radio signals propagate into space for a while, then stop. After a few hundred years, the expanding sphere of their broadcasts becomes so diluted by distance that it's indistinguishable from background noise. Their atmospheric changes might persist for thousands of years, then geological processes restore equilibrium. Carbon dioxide gets absorbed by oceans and rocks. Pollutants break down or get buried in sediment. Given enough time, a planet's atmosphere returns to something resembling its pre-industrial state. Their structures erode, their machines corrode, their cities crumble. After 1,000,000 years, you'd be hard-pressed to detect that they ever existed, even if you could visit the planet and dig around. This is the terrifying implication of the Silurian hypothesis. Maybe the galaxy is full of dead civilizations. Maybe intelligence arises regularly, but doesn't last long in cosmic terms. Maybe we're not alone, we're just late to a party that's already ended dozens or hundreds of times. And these are just the sites we've found accidentally. How many others might exist in deeper water or buried under more sediment or in areas that haven't been surveyed? The continental shelves around the world contain vast areas that were dry land 100,000 years ago. If we wanted to systematically search for evidence of ancient coastal civilizations, we'd need to survey millions of square miles of ocean floor. The cost would be astronomical. The time required would be decades for unclear payoff. Most of what we'd find would be natural geological formations. Probably 99.9% of suspicious features would turn out to be rocks that just happen to look regular. But that 0.1%, that might rewrite history. Nobody's funding that kind of speculative research. We focus archaeological resources on sites we know exist, cultures we can study through artifacts and texts, time periods we can understand through established methodological frameworks. Looking for a hypothetical lost civilization in the ocean is considered fringe science, not because it's impossible, but because it's not a productive use of limited research funding when there are so many known sites that need study. Here's another thought experiment. Let's say you're part of an advanced civilization 100,000 years ago. You've built cities, developed sophisticated technology, accumulated vast amounts of knowledge over thousands of years of continuous cultural development. Then something goes wrong. Maybe climate shifts and your agriculture fails. Maybe disease sweeps through your population and decimates your cities. Maybe resource depletion leads to wars that destroy your infrastructure. Maybe a natural disaster like a volcanic eruption or asteroid impact disrupts your civilization beyond recovery. Or maybe nothing dramatic happens. Maybe just the slow, grinding pressure of environmental change. Your climate becomes less favorable. Your population slowly declines. Your cities gradually empty as people move to more viable regions. Your sophisticated technologies become too expensive to maintain as your population and resource base shrink. Over centuries, your civilization contracts. The outlying cities are abandoned first, then the secondary centers. Eventually, only a few core areas remain inhabited, and even those are shadows of their former glory. The knowledge begins to fade. Without large populations to support specialized schools and training programs, expertise is lost. The master astronomers die, and their students don't have the resources to continue the work. The skilled engineers pass away, and their techniques die with them because there's no longer demand for massive construction projects. Writing might be forgotten if it was only used by a small elite for record keeping and trade, and those functions are no longer necessary in a smaller, simpler society. Within a few generations, people remember that ancestors once had great knowledge, built great things. But the specifics are lost. They remember glass-making existed, but not the exact temperatures and ingredients. They remember ancestors could predict eclipses, but not the mathematical models involved. They remember great cities, but not how they were engineered. The knowledge becomes myth. Ancestors were powerful and wise. They lived in a golden age when everything was better. Gods walked among them. They could do things we can't. This is a pattern we see throughout history. Every culture has myths about earlier ages of greatness. The Greeks told stories about heroic ages that came before them, when men were stronger and gods were more involved in human affairs. Hindu cosmology describes cycles of civilization, with previous ages being more spiritually advanced. Chinese legends speak of sage kings with impossible wisdom. Norse mythology describes a previous world before this one. Mesoamerican cultures had similar cyclical views of history. We usually interpret these as pure mythology, invented stories explaining why the world is the way it is, or providing moral lessons, or giving people a sense of cultural continuity. But what if some of them are distorted memories? What if bits of genuine historical information survived in oral traditions for tens of thousands of years, becoming more fantastical and mythologized with each retelling? The Aboriginal Australians prove this is possible. They have oral traditions describing coastlines that were submerged over 10,000 years ago. The stories describe specific geographic features, bays and headlands and rivers that existed when sea levels were lower. Geologists have confirmed that yes, the coastlines really did look like the stories say, back during the Ice Age, when those areas were above water. That's 10,000 years minimum of accurate transmission through oral tradition. Over 400 generations of people passing stories to their children, maintaining geographic details through all that time without writing anything down. These are all inland regions or areas that have been continuously inhabited for thousands of years. We study them because they have visible ruins, because later civilizations built on top of earlier ones, because the archaeological record is rich and accessible. But 100,000 years ago, the world looked completely different. Sea levels during the Ice Age were 300 to 400 feet lower than today. Huge amounts of currently underwater land were above water and habitable. The entire Persian Gulf was a fertile river valley. The Mediterranean coast extended miles beyond its current shoreline. The English Channel didn't exist. Britain was connected to Europe by dry land. Indonesia wasn't a chain of islands, it was connected to mainland Asia as a single landmass called Sunderland. Australia and New Guinea were connected. There were land bridges across what's now the Bering Strait connecting Asia to North America. The Caribbean had more land area. The coastlines of every continent were dramatically different. If an advanced civilization existed 100,000 years ago, where would they have built their cities? Same place we do, along coastlines and river valleys. That's where the resources are. Access to water for drinking and irrigation, fish and shellfish from the ocean, river systems for transportation, flat land near water for agriculture if they developed it, natural harbours for boats. Every major modern city is near water. New York, London, Tokyo, Shanghai, Mumbai, Los Angeles, all located on coasts or major rivers. That's not coincidence. That's basic settlement logic that applies to any human civilization, which means if an advanced civilization existed 100,000 years ago and followed the same logic, they built their major population centers along coasts and rivers that are now hundreds of feet underwater, and we have barely explored the ocean floor. We've mapped more of Mars than the bottom of our own seas. We have better topographic maps of the moon than we do of most of the ocean. Underwater archaeology at depths of 300 feet is incredibly difficult and expensive. You need specialized equipment, trained divers, proper funding, and you need to know where to look. The ocean floor is vast. Millions of square miles of continental shelf that was dry land during the Ice Age, now buried under water and sediment. Finding specific sites would require systematic survey of enormous areas. A few potentially artificial underwater structures have been found. The Yonaguni Monument near Japan is a rock formation with features that look almost architectural: straight edges, right angles, what appear to be carved steps and platforms. Most geologists think it's natural. Sandstone can fracture in very regular patterns, creating geometric shapes that look artificial but aren't. The rock type and geological context suggest natural formation, but a minority of researchers argue it shows signs of human modification, that natural formations were enhanced and shaped by people, that it's too regular, too organized to be purely natural. The dating is problematic. If it's artificial, it would be at least 10,000 years old. Possibly much older, depending on when that area was last above water. There's no historical record of a civilization in that region with the capability to create such structures. So either it's natural, or our understanding of ancient Japanese prehistory is incomplete, or it represents something even older that doesn't fit our current models. Dwarka, off the coast of India, is another site. Underwater ruins that some researchers claim are the remains of a legendary city described in Hindu texts. Stone structures, what might be a harbour wall, arranged artifacts. Dating suggests around 9,000 years old, maybe older. If it's a genuine city, it predates most of what we consider ancient urban civilization. It would be contemporary with Göbekli Tepe, another site that challenged conventional understanding of prehistoric capabilities. Then there's the Bimini Road in the Bahamas, a linear arrangement of limestone blocks that some claim is an ancient road or wall now submerged. Most geologists think it's a natural formation called beach rock, where calcium carbonate cements beach sand and shells into rock. But the arrangement is very regular. The blocks are fairly uniform in size and shape. It runs in a fairly straight line for over half a mile. Natural or artificial? The mainstream scientific consensus is natural. But there's just enough ambiguity to keep the debate alive. The problem with all these sites is the same. They're on the edge of plausibility. They could be natural formations that happen to look artificial. They could be simple structures created by known ancient cultures. Or they could be evidence of something older and more sophisticated that doesn't fit our current understanding. Without extensive excavation and analysis, which is difficult and expensive underwater, we can't be certain. There are similar megalithic sites around the world, enormous stones moved and positioned with precision that seems disproportionate to the apparent technology level. The standard explanation is always the same: patient labor, simple machines, lots of time. And this is probably correct in most cases, but occasionally you find things that push the limits of what seems possible with the tools we think they had. The Antikythera mechanism, which we discussed earlier, is a good example. It's not impossible with ancient technology. Greeks had access to bronze, knew basic gear mechanics, had sophisticated mathematical knowledge, but it's so much more advanced than anything else from that era that it suggests a whole missing tradition of mechanical engineering that didn't survive. If the shipwreck hadn't preserved it, we'd have no idea Greeks could build such devices. And if only one was ever made, or if this was the only one to survive, we might be looking at a unique example of technology that existed but left almost no trace. What else might have existed and left no trace? What other technologies might ancient people have developed to high levels, then lost when social conditions changed? The Romans had concrete that could set underwater and was, in some ways, more durable than what we made until the 20th century. They built harbour walls and buildings that have survived 2,000 years of seawater exposure, while modern concrete structures in similar environments need constant maintenance. The formula was lost after the fall of Rome. For over 1,000 years, we couldn't replicate it. Only in the past few decades have materials scientists figured out approximately what the Romans were doing. If we didn't have Roman ruins to study, we wouldn't know the formula ever existed. It would be lost knowledge, vanished without a trace, except for mysterious structures that seemed more durable than they should be. Damascus steel is another example. Blades made in the Middle East between about 1100 and 1700 AD had properties that modern metallurgists struggle to explain. They were extremely hard, yet flexible, held sharp edges longer than other steel, and had distinctive wavy patterns. The technique disappeared around 1750 AD. Despite extensive research, we still can't fully replicate historical Damascus steel. We can make modern blades with similar properties using different techniques, but the original method is lost. These are technologies that vanished after just a few centuries of disuse. Imagine what could be lost over 100,000 years of cultural disruption, climate change, and population movement. Now consider a more unsettling possibility. What if there are artifacts from an ancient advanced civilization, but we've categorized them as something else? The Baghdad battery is a clay jar from roughly 2,000 years ago found in Iraq. It contained a copper cylinder and an iron rod. When filled with acidic liquid like wine or vinegar, it generates a small electrical current. A few volts, nothing dramatic, but measurable. Was it actually a battery? Academics argue endlessly about this. Maybe it was used for electroplating jewelry. Maybe it was a storage container that happened to create a chemical reaction. Maybe the dating is wrong and it's not as old as claimed. Maybe the components were placed together accidentally. But it exists. It works as a battery. And it suggests ancient people were experimenting with electrochemistry long before the official invention of the battery by Alessandro Volta in 1800. If it is a battery, what were they using it for? Electroplating seems most likely, but we don't know for sure. And if they were experimenting with electricity 2,000 years ago, what else might they have discovered and then forgotten? Greek mythology talks about automatons, mechanical servants created by Hephaestus, the god of craftsmen, usually dismissed as pure fantasy. But we know Greeks could build mechanical devices of considerable sophistication. The Antikythera mechanism proves that. Is it possible they built other mechanical devices that didn't survive? Automated door openers for temples, which we know existed, water clocks that regulated mechanical displays, sound effects machines for theatrical performances? None of these would survive 2,000 years if they were made primarily from wood and bronze in coastal cities that are now underwater or rebuilt dozens of times. We might have fragmentary evidence of advanced ancient capabilities, but we categorize it as religious objects, art, or mistakes because we don't have the context to understand what they really were. Consider the possibility that we've been looking in the wrong places. Most archaeology focuses on areas where we know ancient people lived: Mesopotamia, Egypt, the Mediterranean, the Indus Valley, China, Mesoamerica. Most academics dismiss claims of encoded mathematics in ancient structures as pattern seeking. Humans are excellent at finding patterns, even when no pattern exists. Our brains are wired to do this, but not always. Sometimes the patterns are real. Sometimes the mathematics really is deliberate. The challenge is distinguishing genuine encoded information from coincidental numerical relationships. When you have enough numbers, some of them will accidentally approximate important constants. Still, it makes you wonder. If you were trying to send a message across 100,000 years and you knew everything you built would erode and every language you wrote in would become unintelligible, mathematics and astronomy might be your only options. You'd have to make it obvious enough to be noticed, but sophisticated enough to clearly indicate intelligence. You'd have to account for the fact that your structures would degrade, so the relationships would need to remain detectable even when precision was lost. It's a nearly impossible problem, which is probably why we don't have any clear examples of such messages, either because no one tried or because they tried and we haven't recognized the message yet. Now let's talk about the really weird possibility. What if the evidence is right in front of us and we're just not recognizing it? There are anomalies in human history that don't quite fit the standard narrative. Not evidence of ancient aliens or supernatural intervention, but genuine mysteries that suggest our ancestors were doing things we don't fully understand. The precision of ancient stonework, for instance. Not just cutting blocks, but fitting them together with such accuracy that you can't slide a knife blade between them. No mortar, just stone on stone with tolerances measured in fractions of a millimeter. The Inca did this at Machu Picchu, Sacsayhuaman, and dozens of other sites. Some of their constructions fit together so perfectly that they've survived major earthquakes that destroyed more modern buildings built right next to them. The stones aren't regular blocks. They're irregular, complex shapes with multiple angles and curves. Each stone is unique, fitting into its neighbors like three-dimensional jigsaw puzzle pieces. How did they do it? We have theories. Probably involved careful measurement, lots of trial and error, techniques passed down through generations of master builders who spent their entire lives perfecting the craft. The standard explanation is that they used stone hammers to pound softer stones into shape, checking fit repeatedly until it was perfect. This is plausible. We know they had the tools and the patience. But some of the oldest examples are actually more impressive than later ones. As if knowledge was being lost over time rather than gained. As if earlier builders knew something that later generations forgot. There are stones at Pumapunku in Bolivia that look machine-cut. Perfectly flat surfaces, precisely measured angles, intricate geometric patterns carved with such consistency that they look like they came from a factory. Conventional explanation: very skilled stoneworkers with lots of time and access to hard stone tools like dolerite hammers. This is probably correct, but the precision is remarkable. Some surfaces are flat to within a fraction of a millimeter across several meters. Some angles are precise to a few arc minutes. This is the kind of precision we associate with machine tools, not handwork. Could ancient people achieve this? Absolutely. With enough skill, time, and quality tools, yes. But it's impressive enough that it makes you wonder whether they knew techniques we've forgotten. Then there are massive stones that were moved and placed with apparent ease. At Baalbek in Lebanon, there are blocks in the foundation that weigh over 800 tons. That's 1.6 million pounds per block. These aren't roughly cut blocks. They're precisely dressed stones, carefully fitted into place as part of a foundation that later Romans built a temple on top of. The Roman construction is impressive. The earlier foundation is in a different league entirely. We can move 800-ton stones today. We have massive cranes, hydraulic systems, computer-controlled positioning. It's difficult and expensive, but we can do it. How did ancient people do it? We assume ramps, rollers, possibly sledges, enormous amounts of human labor organized over years or decades. This is reasonable. Given enough workers and enough time, you can move very large stones using simple machines. But the precision is strange. These aren't roughly positioned blocks that were good enough. They're dressed and fitted as if weight was no obstacle at all, as if whoever placed them had complete control over positioning. This wasn't a simple camp or seasonal gathering site. This was monumental architecture created by people who supposedly had just barely figured out how to stop wandering and settle down. If hunter-gatherers 11,500 years ago could build Göbekli Tepe, what could humans 100,000 years ago have built? We don't know because we're not looking. Or rather, we're looking, but we don't recognize what we're seeing because it doesn't match our expectations. Archaeologists are trained to recognize certain patterns: pottery shards, stone tools, fire pits, post holes from wooden structures. These are the signatures of human occupation that we know how to find and interpret. But what if an ancient civilization didn't use pottery because they had better containers made from organic materials that rotted away? What if their tools were made from materials we wouldn't recognize as artificial? What if they built in ways that leave traces we don't know how to identify? We might walk right past evidence of advanced ancient activity because we're not looking for the right things. Think about this from another angle. If you wanted to leave a message for the far future, knowing that everything you build will eventually erode away, how would you do it? You couldn't use language. Languages evolve and die constantly. English didn't exist 1,000 years ago in a form modern people could understand. Old English looks like a foreign language. Middle English is barely comprehensible without training. Go back 2,000 years and you're looking at Latin, ancient Greek, Aramaic, languages that needed decades of scholarly effort to decipher from surviving texts. By 100,000 years in the future, no one would be able to read anything you wrote. The language would have evolved beyond recognition, split into thousands of descendant languages, maybe died out entirely and been replaced by something unrelated. You couldn't rely on buildings or monuments. We've established those erode away. You couldn't use electronic storage. Hard drives fail within decades. Even if you used the most durable storage medium we know, it would degrade long before 100,000 years passed. So what could you use? Astronomy might work. The positions of stars change slowly over thousands of years due to axial precession. If you built monuments aligned to specific celestial events, future civilizations might be able to backward calculate when you existed based on when the alignments were precise. Many ancient sites have astronomical alignments. Stonehenge aligns with the summer solstice sunrise. The pyramids align with cardinal directions to precision of a fraction of a degree. The Temple of Angkor Wat in Cambodia encodes astronomical information in its architecture. Chichen Itza in Mexico has a pyramid where the shadow pattern on the equinox creates the illusion of a serpent descending the stairs. This requires precise understanding of solar angles and careful architectural planning. We usually interpret these as calendar systems or religious sites, people tracking seasons for agricultural purposes or worshipping celestial objects. But what if some of them are time capsules? What if the alignments encode information beyond just marking solstices? The problem is distinguishing between practical astronomical markers and deliberate encoded messages. When you build something large and want it oriented properly, aligning it to celestial north makes sense for purely practical reasons. That doesn't mean you're trying to send a message to the future. Mathematics might be another option. Certain mathematical relationships are universal. Prime numbers, pi, the golden ratio, the Fibonacci sequence. These aren't cultural constructs. They're inherent properties of mathematics that any sufficiently advanced civilization would discover. If you encoded mathematical information into architecture or artwork, it would theoretically be recognizable to any civilization that had developed mathematics to a similar level. Some researchers claim ancient monuments do exactly this. The Great Pyramid supposedly encodes pi in the ratio of its height to the circumference of its base. The dimensions supposedly relate to the size of the Earth. The spacing of stones supposedly reflects astronomical distances. The problem is that when you measure enough things, you'll find mathematical patterns purely by chance. This is called the Texas sharpshooter fallacy. You fire a bunch of bullets at a barn, then paint a target around the cluster and claim you're a sharpshooter. Similarly, if you measure every dimension of a complex structure, calculate every possible ratio, you'll eventually find relationships that approximate important mathematical constants. That doesn't mean they were deliberately encoded. It might just be coincidence. Carbon dioxide from burning coal or oil has a particular isotopic signature. If an ancient civilization had an industrial phase, you might find a thin layer in the geological record with anomalous carbon ratios, a spike in atmospheric CO2 that shows up in ice cores or sediment layers. Except, we'd need to know where to look. The geological record isn't evenly preserved everywhere. Most of it gets recycled through plate tectonics, eroded away, or buried so deep we can't access it. We have decent, detailed records for maybe 1% of Earth's surface going back 100,000 years. If an ancient civilization occupied 1% of the land area, and we have good records for 1% of the relevant time period, we're looking at a 0.01% chance of randomly sampling the right location and time period. Those are terrible odds. It's like trying to find a specific grain of sand on a beach, except you're blindfolded and the beach is the size of Texas, and that's assuming the chemical signatures are even distinguishable from natural geological processes. Earth does weird chemistry on its own. Volcanic activity releases CO2 with various isotopic signatures. Natural coal seams can catch fire and burn for centuries. Methane seeps from the ocean floor. Asteroid impacts vaporize carbon-rich rocks and inject weird chemistry into the atmosphere. You might find a layer with unusual carbon isotope ratios. Is it evidence of ancient industry, or just a natural event we don't fully understand, or a volcanic eruption that happened to burn through a deposit of organic material? Without multiple independent lines of evidence, you can't tell the difference. And finding multiple independent lines of evidence from 100,000 years ago is nearly impossible. Second piece of possible evidence: artifacts in impossible locations. Objects or structures that don't match the supposed technology level of the time period. We found these. The problem is figuring out what they mean. The Antikythera mechanism is the famous example. Discovered in a shipwreck off the Greek island of Antikythera in 1901, it's a 2,000-year-old device containing dozens of precision gears that tracked astronomical positions and predicted eclipses. When it was first discovered, archaeologists didn't know what to make of it. The technology was so advanced that many assumed it couldn't be as old as the shipwreck. It had to be a later intrusion, or the dating was wrong or something. Then, X-ray analysis in the 1970s and 2000s revealed the full complexity. It was genuinely ancient, genuinely sophisticated, and genuinely unlike anything else from that time period. It's a mechanical computer that tracked the positions of the sun, moon, and planets using gear ratios that encoded sophisticated mathematical understanding of orbital mechanics. Nothing even close to this level of mechanical complexity appears in the archaeological record again until the 14th century European clocks. That's a 1,400-year gap. So what does the Antikythera mechanism tell us? That ancient Greeks were far more technologically sophisticated than we usually assume. That our understanding of ancient capabilities is incomplete. That technologies can appear, reach high levels of development, then completely disappear when the social conditions that supported them collapse. But it's only 2,000 years old. We have historical records from that period. We know Greeks and Romans were advanced mathematicians, engineers, and astronomers. The mechanism is surprising, but not inexplicable. What about things that are older? Much older. There are stone structures around the world that date back 10,000, 20,000, even 30,000 years or more according to some controversial dating methods. Most are dismissed as natural formations. Some are clearly artificial, but we assume they're just simple constructions by hunter-gatherers who didn't have anything better to do. But what if we're wrong about some of them? What if a few of these sites are remnants of something more sophisticated, but we can't recognize them because they've been so degraded by time? Göbekli Tepe in Turkey completely upended our understanding of what was possible in the ancient world. It's about 11,500 years old, which makes it older than agriculture, older than pottery, older than metal tools. It's also massive. Stone pillars weighing up to 20 tons carved with intricate animal figures and abstract symbols arranged in circular structures that required coordinating hundreds of workers. Some of the stones had to be quarried, shaped, and transported from locations over a kilometre away. With thousands of years of this systematic botanical research, how advanced could that knowledge become? You could have a complete pharmacopoeia of plant-based medicines, some of which might be more effective than synthetic drugs we use today. You could develop social technologies, systems of government conflict resolution, resource distribution that we've never imagined because our civilization went a different route. Some hunter-gatherer societies have conflict resolution systems that anthropologists consider more sophisticated than modern legal systems in certain ways. The Kung people of southern Africa have methods for resolving disputes that prevent feuds from developing while maintaining social cohesion. These evolved over thousands of years of cultural development. Given 25,000 years, you could refine social technologies to levels we can barely imagine. Ways of organizing large populations without centralized authority, methods for distributing resources that prevent inequality without requiring complex bureaucracy, techniques for preventing violence that work better than our current legal systems. Most importantly, you could accumulate knowledge, not through writing necessarily, though that's one method, through oral traditions refined over hundreds of generations, through apprenticeship systems where masters teach students for decades, through monuments and artistic depictions that encode astronomical and mathematical information. The Maya did this. Their hieroglyphic writing wasn't just phonetic, it was also logographic and symbolic, encoding multiple layers of meaning in single glyphs. A text could be read as historical record, astronomical data, mythological narrative, and mathematical calculation simultaneously. Polynesian navigators did this, maintaining detailed mental maps of ocean currents, star positions, wave patterns, and island locations across millions of square miles of Pacific Ocean without written charts. They could navigate from Hawaii to New Zealand using only observations of nature and knowledge passed down through oral tradition. This knowledge was so detailed that modern scientists studying Pacific navigation had to admit that in some ways, traditional navigators understood ocean dynamics better than people with GPS and satellite data, because they'd been observing and refining their knowledge for thousands of years. Aboriginal Australians preserved oral histories spanning over 10,000 years, describing coastlines and landmarks that have been underwater since the last ice age. Geologists have confirmed that yes, the stories accurately describe landscape features that existed when sea levels were lower. That's 10,000 years of accurate information transmission through oral tradition alone, stories passed from generation to generation, maintaining geographic and historical details through 400 generations of people who never wrote anything down. If these techniques can preserve knowledge for 10,000 years, why not 50,000? Why not long enough to build something genuinely advanced? But okay, let's say such a civilization existed. What would the evidence look like today? First, forget about finding intact buildings or recognizable artifacts. Those would be gone, completely gone. Wood rots within decades in most climates. Stone erodes, metal corrodes. Even the most durable materials break down given enough time and the right conditions. The pyramids of Giza are only 4,500 years old, and they're already heavily eroded despite being made of limestone in one of the driest places on Earth. The outer casing stones that once gave them smooth sides have almost entirely disappeared. The precise geometry is degraded. Give them another 95,000 years and they'd be unrecognizable mounds of rubble. The internal chambers would collapse, the careful alignment to cardinal directions would be obscured. They'd look like natural hills with unusually regular shapes, and only detailed analysis would reveal they were artificial. The Great Wall of China is about 2,000 years old in its current form, though some sections are older. Already, large portions have crumbled to almost nothing. In rural areas where maintenance hasn't been performed, you can walk along the route and barely recognize that there was once a continuous structure. In 100,000 years, it would be a vague line of disturbed soil and rock scatter across a landscape that's been reshaped multiple times by climate shifts, erosion, and geological processes. You might notice the anomaly in satellite imagery if you knew what to look for, but you wouldn't look at it and think ancient wall. So what would survive? Certain chemical signatures in geological layers might persist. An industrial civilization burns fossil fuels or processes minerals in ways that create specific isotope ratios in the atmosphere. Some of these get incorporated into rock layers and can persist for millions of years. This isn't speculation. We know sea levels were dramatically lower 100,000 years ago. The most attractive places for human settlement have always been coastal areas and river valleys. Access to water, abundant food sources, natural harbors for boats, flatland for building. If an ancient civilization followed the same logic we did, they built their major population centers along coasts and rivers, and every single one of those locations is now either underwater or has been so heavily modified by changing river courses that original settlements would be buried under meters of sediment. What if their technology was based on principles we've forgotten or never discovered because we went a different direction? This happens all the time in recent history. The Romans had concrete that could set underwater and was more durable than what we made until the 20th century. The formula was lost for over 1,000 years. Damascus steel had properties we still can't fully replicate. The technique disappeared. These are technologies that vanished after just a few centuries of disuse. Imagine what could be lost over 100,000 years. Let's think about what 100,000 years actually means. Not as an abstract number, but as a span of time for human development. Modern civilization, from the first cities in Mesopotamia to today, spans maybe 6,000 years. In that time, we went from mud bricks and copper tools to smartphones and spacecraft, from donkeys as our primary transportation to vehicles that can leave the planet, from writing on clay tablets to a global internet that lets anyone communicate with anyone else instantly. That's 6,000 years of development. Pretty impressive, right? 100,000 years is 16 times longer than that. If an advanced society emerged 100,000 years ago and developed at even a quarter the pace we did, they would have had 25,000 years of continuous development. That's 4 times longer than the entire span of recorded history. What could you accomplish in 25,000 years of continuous development? Start with the basics. You could master architecture without steel by understanding stress distribution, load-bearing principles, and using sophisticated joinery techniques with wood and stone. You could create massive structures that utilized natural geological formations as integral components. The Inca did this at Sacsayhuaman, fitting enormous stone blocks together without mortar, using only stone tools and deep understanding of structural engineering. The blocks are so precisely fitted that earthquakes which destroy modern buildings leave these ancient walls intact. Now imagine refining those techniques for 25,000 years instead of the few centuries the Inca had. You could build cities into cliffsides like Petra or Mesa Verde, but far more extensively. You could create networks of underground chambers for climate control, water storage, and protection from surface disasters. You could engineer water management systems that worked entirely with gravity and geological pressure rather than pumps. The Romans built aqueducts that carried water for hundreds of miles using nothing but careful grading and stone construction. Some are still functioning 2,000 years later. With 25,000 years of development, you could create hydraulic systems of breathtaking sophistication, all using pre-industrial technology. You could develop complex astronomical knowledge, tracking planetary movements and seasonal changes with such precision that you'd know more about celestial mechanics than most modern people. Not because you had telescopes, but because you had centuries of continuous observation and mathematical modeling. The Maya did this. With no optical instruments beyond the naked eye, they calculated the length of the solar year to within minutes of the correct value. They predicted eclipses centuries in advance. They tracked the movements of Venus with precision that rivals modern observations. They did this in maybe 2,000 years of systematic astronomical observation. Give a civilization 25,000 years, and they could have encyclopedic knowledge of celestial mechanics encoded in monuments and maintained through specialized schools of astronomer priests. You could create sophisticated pharmacology based on plant chemistry. Ancient peoples definitely developed antibiotics, pain relievers, contraceptives, and psychoactive drugs from natural sources. Willow bark for pain relief, which led to modern aspirin. Foxglove for heart conditions, which led to digitalis. Cinchona bark for malaria, which gave us quinine. These weren't lucky accidents. They were the result of systematic experimentation over generations. People testing different plants, noting effects, refining preparations, passing knowledge to apprentices. In the past 100,000 years, Earth has been through multiple ice ages. Glaciers advanced from the poles, covering huge portions of the northern continents under ice sheets kilometers thick. Then they retreated, then advanced again. Each time, they acted like continental-scale bulldozers, scraping away soil, grinding down bedrock, pulverizing everything in their path. The Great Lakes exist because glaciers carved them out. The Finger Lakes in New York, the fjords of Norway, the U-shaped valleys of the Alps, all created by ice grinding through the landscape with unstoppable force. If you had a city in the path of a glacier, it wouldn't just be destroyed, it would be erased, ground into gravel and scattered across hundreds of miles. The finest architectural achievement would become an undifferentiated pile of sediment mixed with natural rock. Sea levels have fluctuated by 400 feet or more. During ice ages, so much water gets locked up in glaciers that ocean levels drop dramatically. Coastlines extend hundreds of miles beyond their current positions. The entire Persian Gulf becomes dry land. Britain connects to mainland Europe. Indonesia becomes part of Asia. Then the ice melts and everything floods again. Any coastal settlements get drowned under hundreds of feet of water and buried under layers of marine sediment. By the time 100,000 years have passed, the planet has essentially resurfaced itself multiple times over. What we see today is not what someone would have seen back then. The landscape has been rearranged, eroded, buried, exposed, frozen, flooded, and transformed so thoroughly that almost nothing survives unchanged. This is the central problem with detecting ancient civilizations. We're not looking at a preserved crime scene. We're looking at a crime scene that's been hit by earthquakes, floods, fires, and ice sheets, then rebuilt 50 times with new crimes committed on top of the old ones. The evidence isn't just hidden, it's been actively destroyed by the most powerful forces on the planet operating continuously for 100,000 years. But let's back up and ask the fundamental question: could an advanced civilization even have existed 100,000 years ago? The knee-jerk reaction is no. Everyone knows civilization started maybe 12,000 years ago with agriculture in the Fertile Crescent. Then cities appeared around 6,000 years ago in Mesopotamia and Egypt. Before that, humans were just hunter-gatherers living in small groups, making stone tools, barely scraping by, right? But here's what that story gets wrong. It assumes technology and civilization follow a straight line, that you can't have sophistication without agriculture, can't have large settlements without writing, can't have complex engineering without metal tools. What if that's just the path our civilization took? What if there are other paths we never explored because we didn't need to? Consider this. Anatomically modern humans, people whose skeletons are indistinguishable from ours, have existed for about 300,000 years. That's a fact supported by fossil evidence from sites across Africa. Behaviorally modern humans, with brains essentially identical to ours in size and structure, have been around for at least 100,000 years, probably longer. The archaeological record shows sophisticated tool use, symbolic thinking, and complex social behavior going back well over 100,000 years. That means someone living 100,000 years ago had the same cognitive abilities you do, same capacity for language, abstract thinking, problem solving, long-term planning, same ability to innovate, to teach, to accumulate knowledge across generations. Their brains worked exactly like yours. Put a baby from 100,000 years ago in a modern home, and they'd grow up completely normal, indistinguishable from any other kid. They'd learn to read, use computers, do calculus, because cognitively they were us. So why don't we think they built anything? Because we assume building requires certain preconditions. Metal tools, written language, domesticated plants and animals. But those are our solutions to problems. They're not the only possible solutions. What if an ancient civilization used primarily organic materials? Wood, plant fibers, bamboo, animal products, materials that completely decompose in centuries, let alone millennia. The Inca built massive suspension bridges entirely from woven grass. They lasted for centuries with proper maintenance, but would leave almost no archaeological trace if abandoned. You'd find maybe some stone anchor points if you were lucky. The actual bridges? Gone completely. Polynesian cultures built ocean-going vessels capable of crossing thousands of miles of open water. These boats were technological marvels, but they were made from wood, plant fibers, and natural resins. None of it would survive even a few hundred years in most environments. What if they built on coastlines that are now 300 feet underwater because sea levels were lower during the Ice Age? You know that feeling when you realize the story you've been told your entire life might be incomplete? Like when you find out your parents had whole lives before you existed, relationships and adventures you never heard about. That's what we're facing with human history. Except it's not just decades we're missing. It's potentially 100,000 years of advanced development that came and went before anyone was around to remember it. And here's the really crazy part. We might never be able to prove it existed, even if it did. The question isn't whether we want to believe in lost civilizations. The question is whether our planet would even preserve evidence of one that existed so long ago. And the answer to that question is deeply unsettling. The story starts with a guy named Gavin Schmidt at NASA's Goddard Institute for Space Studies just a few years ago. He's running climate models, trying to understand how future civilizations might detect evidence of our current industrial age in geological records millions of years from now. Standard stuff for a climate scientist thinking about deep time. Then he realizes something that stops him cold. If you go back far enough in Earth's history, if you really think about what geological processes do over tens of thousands of years, the evidence for an advanced civilization would be incredibly difficult to find. Not impossible, but so subtle, so degraded, so scattered that you might look right at it and never know what you were seeing. He spends months wrestling with this idea, running calculations, checking with colleagues, making sure he's not missing something obvious. Because the implications are staggering. If an industrial civilization existed on Earth millions of years ago, we might have no way of knowing. The geological record just doesn't preserve that kind of detail over such vast timescales. He publishes a paper with an astrophysicist named Adam Frank in 2018. They call it the Silurian hypothesis, named after a Doctor Who episode about intelligent reptiles that supposedly ruled Earth before humans. It's a thought experiment. Could we detect an industrial civilization in Earth's geological record if one existed millions of years ago? Their conclusion is terrifying in its implications. After just a few million years, almost nothing would remain. Cities would erode to dust, roads would be ground down by glaciers, plastics would break down into microparticles and scatter, metals would corrode and disperse, even radioactive waste would decay beyond easy detection. And after 100,000 years, you'd be looking for needles in continent-sized haystacks, and most of the needles would have rusted away to nothing. Now you might think, okay, so ancient evidence disappears. Big deal. Obviously, there was no advanced civilization 100,000 years ago because we haven't found cities, roads, factories, landfills full of plastic that would last forever. Wrong. Nothing lasts forever. And 100,000 years is an eternity for the forces that reshape our planet's surface. Think about what happens to a modern city if humans just vanish. Scientists have modeled this extensively. Within 20 years, buildings start to collapse, roads crack and buckle as plant roots work their way through pavement. Within 100 years, most wooden structures have rotted away completely. Within 500 years, even steel and concrete buildings are crumbling ruins, overgrown with vegetation. Give it 1,000 years, and you'd struggle to recognize that a city ever existed in most locations. Maybe some foundations remain, maybe fragments of the most massive structures, but most of it, gone. Reclaimed by nature. That's just 1,000 years. Now multiply that by 100. Think about what Earth does to coastlines in just a few thousand years. Entire cities that existed 3,000 years ago are now underwater or buried under meters of sediment. Ancient Alexandria in Egypt had whole districts that are now beneath the Mediterranean. The original coastline is hundreds of meters from where it used to be. Earthquakes rearrange landscapes in minutes. The 1964 Alaska earthquake lifted some areas by 30 feet and dropped others by the same amount. Imagine that happening dozens of times over 100,000 years. The entire geography changes. Erosion grinds down mountains at rates of a few millimeters per year. That doesn't sound like much until you multiply it out. Over 100,000 years, that's 100 to 200 meters of vertical elevation change in some areas. Entire mountain ranges get worn down and redeposited as sediment in valleys and ocean basins. Rivers change course constantly. The Mississippi River has moved its mouth hundreds of miles over just the past few thousand years. Over 100,000 years, a river system might carve entirely new valleys and abandon old ones, covering ancient settlements with meters of flood deposits or exposing them to erosion, and that's all assuming relatively stable climate. But climate isn't stable over 100,000-year timescales. Today, there are over 8 billion humans living on Earth. We've mapped every continent, built cities that scrape the sky, sent probes beyond our solar system. We think we know our planet's history. We think we're the first and only civilization to reach this level of sophistication. We're not even close to being sure about that. Because buried beneath our feet, scattered across continents, hidden in geological layers that predate recorded history by 90,000 years, there might be evidence of something that rewrites everything we thought we knew about human civilization. If you're using this to fall asleep, that's literally why I make them. So subscribe maybe and tell me where you are and what time. I check comments, and it's like Berlin at breakfast, Boston at bedtime, all at once.